All right, so we've almost determined which one's the fastest. We just determined how quickly Audi was accelerating between the 60 mile per hour and the 100 mile per hour mark. It was 10.53 miles per hour per second. Now we're trying to figure out for BMW and for the Mercedes what their acceleration is so that we can compare them and determine which one is the quickest. So let's do the BMW M8. All right. So first of all, I'm going to find their data points, and that's going to make it easier to put it into the formula, just like we did previously. So let's start with the 60 mile per hour. So that's 2.660. All right. So 2.660 was the first data point, and then the next one for BMW was 6.300. And again, it's always good to label your X and your Y so you can remind yourself which one goes where in the formula. Okay, so we're using the acceleration formula, which again is the same formula that we used to find slope, and it's the same formula that you use in general to find the rate of change of any graph. Okay, so it's delta Y over delta X. Or you can think of it as delta speed over delta time, change in speed over change in time. That's what we're trying to figure out. That's acceleration. So let's take the data points, remind ourselves that this is Y minus Y on top and X minus X on the bottom. All right, so the Y values, I've got 160 again. So again, I'm getting this 40 as the top number. I'm going to get 40 as the top number, right? Next one, I've got 6.3 minus 2.6. And keep that in parentheses. The reason I'm putting parentheses there, guys, is just to remind myself that I need to do that stuff before I do the division. Division happens at the end. But usually in order of operations, if I didn't have the parentheses, I would do the division first, right? So it's nice to have those parentheses there. Again, 100 minus 60 gives me 40, and 6.3 minus 2.6, we're going to try in our Desmos. Okay, 6.3 minus 2.6. 6.3 minus 2.6, that gives me a 3.7. All right, and let's do that division. So 40 divided by 3.7. Gives me this number, and again, I'm going to round if I need to. So I'm looking at the thousandths place is the 0, so that just tells me to stay, right? So 10.81 is my acceleration for the BMW. Okay, so let's write that into a nice sentence here. BMW has an acceleration, or how did I word it? Accelerates. Yeah. Accelerates. I can't spell accelerates, I guess. There we go. Accelerates at 10.81 miles per hour per second. Okay, that's the acceleration. Let's compare it. Which one's faster? 10.3 miles per hour per second or 10.8 miles per hour per second? Remember, acceleration, the larger means the quicker that you are speeding up. So right now, BMW has beaten out Audi. Now we just have to figure out if the Mercedes can beat out the BMW. If it can't, then that means the BMW is the fastest. If it can, that means the Mercedes is the fastest. So we're down to that. We got to figure out the Mercedes. Again, just like before, I'm taking the data points to start. So I've got 3.0 and 60. And I have 7.4 and 100. There we go. Okay. Labeling X, Y, X, Y. Sorry for my sloppiness. All right, let's talk about acceleration. What is it? Delta Y, the change in the Y value over the change in the X values. Right? Change means subtract. So Y minus Y divided by x minus x. So starting with the y values, again, we're comparing the same y values, so it makes sense that we just keep doing 100 minus 60. It's not always going to be the case that every single y values are the same, but in this particular case, we happen to be looking at specific y values when comparing these. We're looking at a specific y value of 60 miles per hour. We're looking at a specific y value of 100 miles per hour. So that's why these values keep turning up. But the x values are changing, right? We've got 7.4 minus 3.0, okay? And this should give us 40, again on top, and the bottom one should give us 4.4, but I'm going to check that in the calculator just to make sure. So 7.0 minus 3. Nope, 7.4. Yep, 4.4. Okay, and so when we want to actually figure out that, we're going to do 40 divided by 4.4, and that gives us this. And now we're noticing, probably have already noticed, that this is ending up being the slowest one. All right, again, we need to look at our thousandths place to determine whether we're rounding or not. So tenths, hundredths, so right here is where I want to go. So I need to look at the one next to it. The one next to it is a 0, so that tells me to just stay where I'm at. So 9.09, which means it is the slowest. Okay, so we're going to say Mercedes see if I can spell. There we go. At 9.09 miles per hour per second. Okay. All right. So we found the accelerations for all three. All right. Now that we found the accelerations for all three, we're going to put it together on the next page. So I'll see you on the next page.